Bienvenidos, Ushamdi, and welcome. CMIT 454, Section 6380 and 6382 learners for the first 8-week term of the spring 2018 semester at the University of Maryland University College. This is the Cisco Networking Academy CCNA Security version 2.0 course, and this morning's Packet Tracer tutorial and solution set is going to be on Packet Tracer activity 11.3.1.1. In fact, this is our final Packet Tracer activity, and this is the Skills Integration Challenge for the course. In other words, this is now going to call into action and application everything that we have learned throughout the term, and we're going to apply that in a single Packet Tracer activity. And it's actually a really, really good Packet Tracer activity. So I'm going to do things a little differently than I normally do. So there is a bug with this activity that's preventing you from getting to 100%. So here's the activity. Let me go ahead and enlarge our topology just a little bit so that we can see things a little bit better. And the bug is that you get the entire activity done. If you complete the activity step by step and manually enter everything in, you're going to get down to the firewall component, and you're going to enter in this allow SSH access from the outside. And a couple of you have run into this already. And then you set the SSH timeout to 10 minutes, and the completion percentage will get stuck at 98. So instead of making you wait until the very, very end of the video, I'm going to explain what I did to get the points. So if I pull the firewall up, and here's the problem that you're going to encounter. If I pull the firewall up and I pull up the CLI, and I go from user exec into privilege exec, and there's no password right now. And let's get into global config. If I manually type in the command that's required, and the command that's required is SSH 172.30.3.3 and then 255 on the outside, right? Because we're allowing the PC that's behind router 3 on coming in on the outside interface to SSH into the firewall. So if I were to hit enter right now, I would expect that either now or when I do the SSH command that I would end up with the points for this, the completion percentage, the needle would move. So I type SSH, and we can ignore that error. We should still get the points even with that error, but we don't. So now I'm going to say SSH timeout 10, thinking, okay, well maybe I need to put the SSH command in here as well, and that's going to get me the completion percentage to 1%. It's going to get me that 1% that I'm well, the 2% that I'm missing, but it's going to move the needle in the grading engine to give me the 100. And you'll notice what happens here, we get nothing. So the completion percentage down here in the lower right still shows 0. So here's what I'm going to do. I'm going to remove these two commands. And this is the most bizarre bug I have ever seen with Packet Tracer. Now, I'm going to go out here to this document that I've got, and I'm going to grab just these two commands here, right? The SSH command and the timeout command. I'm going to come back in, and I'm going to paste those in. So I'm literally only going to cut and paste them in. That's the only difference. Instead of manually entering them in, I'm going to cut and paste them in, and I'm going to hit enter. And you're going to notice that we don't get any points for the completion percentage. Now, this is what's interesting. Watch what happens when I come back and I say no, and we'll remove those two commands. When I grab all three of these commands, right? And the first command is allowing SSH from any host on the inside. The second command is allowing SSH into the firewall on the outside interface, but only from that host 172.30.3.3. And then I'm setting the timeout to 10. When I cut and paste all three of those commands at the same time, we're going to get the 1%, or we should, and there it is. We get the 1%, but here's the thing, is it says 1% there. So you may be thinking, well, that's only going to put me at 99%. No, for whatever reason, when I did this with an activity that was stuck at 98, I pulled the three SSH commands out, tried to manually enter them in, tried changing the order that they were entered in, and then finally I was like, okay, well, let me cut and paste them in to make sure that it's like I'm not typoing something. Boom, you get the 1%, but it shows 1% here. But when the activity's at 98, it pushes it to 100. And when we go to check results, the error that you were seeing, right, or the thing that you were having the red X next to at 98%, which was this management access list access setting, is now correct, right? So this is by far the most bizarre packet tracer, call it bug, call it order of operations, snafu, the shenanigan, right? Whatever you want to call it, this is the strangest thing I have ever seen, is that all three of those SSH access list commands need to go in order, like I just showed you, and they need to be cut and pasted in. I've entered all three of those in manually at 98%, and it doesn't give you the points. I've entered them in manually at 0%, like right now, just from scratch. It does not give you the points. They have to, at least this is my experience. You have to cut and paste all three of those commands in, or it will not give you the points. And so again, I don't want to make you wait until the very, very end of the video, because this is definitely going to be a monster video. I want to get you that information right up front, especially for viewers who are coming in and maybe trying to figure out what is the issue if they're taking the course somewhere else. So that's the issue. All right, now on to the configuration tasks that we are going to have to set up here. So configure basic router security. We're going to do that on router 1. So let's give ourselves a little more space with which to work here on router 1, and let's get to the CLI. So here we are on router 1. We're in user exec as evidenced by that greater than sign. Let's use the enable command to transition to privilege exec, and then configure T or conf T to get into global config. So minimum password length is going to be 10 characters. Now this is early on in the course we talked about this, so you may have to go back and refer to some of the early materials. So this is going to be security, passwords, and again, very straightforward, minimum length. Now remember, we also talked about the fact that NIST has come out recently and changed their thinking on these extremely long passwords being required, that it's actually more unsecure to force users to use passwords that are 12, 15, 18 characters long, and that the password should only be changed under suspicion of the fact that it has maybe been compromised. All right, so security passwords minimum length 10, so we should go from 0% to probably 1. There it is. There's 1%. Encrypt our plain text passwords, right? So this is a service that the router is providing. So we're going to say service password encryption. Whoops, not 10. Service password encryption, and hit enter. And that moves our completion percentage needle as well. So privilege exec mode secret password. So enable secret. Remember, you could say enable password, but that is not what you want. That's going to give us a type 7. We want a type 5 in the activity. In the real world, you want a type 9. You want to change the algorithm type to script. So we say enable secret, and the password is CISCOENAPA 55. So enable secret CISCOENAPA 55. I want to make sure we double check that. All right, and because they add an extra A in there in this activity. Now, console line password is going to be Cisco con PA55. So let's get in line con 0, and let's go ahead and set this. So the password is going to be Cisco con PA55. The timeout is 15 minutes. So how do we do that? Well, what is the exact timeout? Well, we set it to 15. Now, we're not done there. Remember, it's 15 minutes. How many seconds? Well, we're simply going to say 15 minutes and 0 seconds. And then a console messages should not interrupt. Well, we know that that's logging synchronous. Now, you might be looking at this saying, okay, let's say do show. Wait, we just have to say, yeah, we need to see do show run here. So we say do show run. We get down to the end, and you'll notice, take a look at what's here. And again, we didn't type that in on either of these lines, but we've got this login is already there for us. And when we get up to the VTY, I was reading ahead here, you can see it says login is required. Now, it doesn't say that login is required for the console line, but that's already there. So I'm going to leave that there for right now because I don't want this to mess up the scoring engine. But we may need to come back and change that. Okay, now we need a message of the day, right? So how do we do that? So we go into the banner, Motd. I'm going to use the percent sign. Remember, early on in the course, we had some issues where if there was a space here, it may cause an issue. If there was a space at the end, it might cause an issue. So unauthorized, and we'll just say access is prohibited. And then I'm going to put unauthorized just to make sure. And remember, the space at the end, I would avoid that. Let's just go ahead with the percent sign right here. We'll get it all on one line. We're at 5%. The needle should move. If it doesn't, that's an indication. Excuse me, that's an indication that maybe we did it wrong. So we're good. We went to 6%. So now let's go ahead and drive on here. So now we're going to jump onto router 2. So let's pull router 2 up. And we've got a little work that we're going to be taking care of here on router 2. Far fewer tasks here on router 2. So we're in user exec mode. Enable is going to put me into privilege exec. Let's get into global config. The secret password again. So we'll say enable and secret, and it's going to be Cisco. And what are they asking for here? Cisco ENAPA 55. Enable secret Cisco ENAPA Cisco ENAPA 55. Yeah, they changed. You'll notice it used to just be Cisco EN PA 55, and for whatever reason on the last activity, maybe to make us stop and think, they changed it up on us. So there's our enable secret command. That's good to go. Password for the VTY lines. I'm going to say line VTY 0 to 15. Now remember the login, and let's check on router 2 here. It should be down here as well. And it is. And you'll notice on router 1, and see this was odd. Router 1, the login was there. Router 2, it's not for the console line, but it is here for the VTY line. And so we're going to go ahead and say the password is going to be Cisco VTY, CISCO VTY PA 55. All right, so everything looks good right with that. Let's get our exec timeout set to, so exec timeout 15.0, and we should see, and the needle didn't move there. Maybe we're not going to get points on that. I'm paying very close attention to that completion percentage. Knowing that we've got some, could be some possible shenanigans here when we get to the end of the activity. And says login is required. Well, login is already there. I'm going to type login, and I'll be shocked if they give you points for this because it's already there. So no points. Okay, so let's make sure here, do show run. And the password VTY lines, the password for the VTY line should be Cisco VTY PA 55, and that is correct. The timeout, exec timeout 15.0, and login is required. All right, so that takes care of router 2. Now we're going to move to some configure basic switch security, right? So configure the following on switch 1. We've got 3 switches here. Here is switch 1. Let's make that a little larger. Slide it down over here out of the way, and we'll pull our CLI up here. So here we are on switch 1. You can see we're in user exec, the greater than sign. We're going to go to privilege exec with the enable command. And let's get into global config, and we're going to encrypt plain text password. So remember, this is a service that the router, password encryption that the router provides. So service password encryption, privilege exec mode secret. So we're going to go ahead and say enable secret, and it's going to be CISCO ENAPA 55. All right, the console line password. So again, line con 0, and the password is going to be CISCO con PA 55. We want to set our exec timeout to 5 minutes, and console messages should not come on the screen. So logging synchronous, right? Let's make sure that would have gone out there. Logging synchronous. All right, let me make sure we got everything. Should not interrupt. So the VTY lines, line VTY 0 to 15, and The password is going to be Cisco VTYPA55. And we're going to have a timeout of 5 minutes and 0 seconds, and login is required. And I wonder if typing login, yeah, it's interesting. You'll notice it says login is required as part of the instructions, but when we're typing login in, we're not getting points for it because it's already there, or it was in the routers. So let's do a banner, right? Let's exit out here. We're going to do a banner Motd, and we need to make sure that unauthorized is in there. So I'm going to say unauthorized access is prohibited. And let's see, this should move the needle. We should go to 14%, I think, here at a minimum. Yes, okay, good. And again, I'm just keeping a very close eye on little things, right, that we ran into, little quirks with Packet Tracer that we ran into early on in the semester to make sure that we don't end up getting penalized here for something at the end. Now, configure trunking between switch 1 and switch 2 with the following settings. So if I was to say do show interface trunk, right, you can see there are no trunk ports right now. And that could be for a whole host of reasons. We're going to set the mode to trunk. We're going to assign Vlan 99 as the native Vlan. So if I was to pull the activity up just a skosh here, you can see that there's a link between these two switches. Now, this is the first thing that we need to do. You might be able to mouse over. My VM is so slow that it doesn't, for whatever reason, doesn't pull that information up. So here's how I do it, is let's say do show IP interface brief. Because how many interfaces are going to be hot or live enabled on this switch? Should only be 2. So we'll go back up here toward the top. So we see that 6 is up. Now, my guess is that 6 is coming off here to the host, and that 1 is going to be what we're interested in, right? So you can see here fast Ethernet 01 is up. So 1 is either to the host or it's to the other switch. I think it's to the other switch, but let's make sure there are no gigabit Ethernet interfaces involved. And they're not. They're all down. So here's how we're going to handle this. I'm simply going to go into interface fast Ethernet 01, and I'm going to say shut. Now, if I'm right, that is going to go ahead and take us over to that's going to take us, not over to, but it's going to take us to a red dot on that interface. And so then we've confirmed it is fast Ethernet 01. So I'm going to go ahead and say no shut. Now, we're going to let spanning tree work itself out here, but we've got tasks we can do while we wait this 30 to 45 seconds here. So we are going to, let me find my place back up here, configure trunking between, let me get up there, between switch 1 and switch 2. We're going to set the mode to trunk and assign Vlan 99 as the native Vlan. We're going to disable the generation of dynamic trunking protocol frames. In other words, we're going to turn off DTP. So I think we're in interface fast Ethernet 01. I'm going to say switch port mode trunk, right? So it turns that port into a trunk port. I'm going to say switch port no negotiate. That disables. When it's a trunk port, that disables the dynamic trunking protocol. And we're going to say switch port trunk native VLAN, and I'm looking back up here, 99. All right, so did we get, and now we're going to get this native VLAN mismatch coming from CDP, or the Cisco Discovery Protocol. And the reason is we have a native VLAN mismatch, because by default, what is the native VLAN? Exactly. By default, the native VLAN is 1. And this is probably one of the more sort of obvious messages that you're going to get, where when you read it, it's like, oh, this makes complete sense. Native VLAN mismatch discovered on fast Ethernet 01, and it's VLAN 99. And this is the switch that I'm on with switch 2, the remote switch, on their interface, fast Ethernet 01, and they're using 1. So by looking at this message, it is abundantly clear that the native VLAN mismatch is because I'm using VLAN 99 for the native VLAN on fast Ethernet 01 trunk port, and on switch 2, it's using VLAN 1, which is the default. So totally clear what has to be done here in order to resolve the issue. We need to fix it on switch 2, and again, the message pops back up every time CDP goes to send its message. So let me double check here. So set the mode to trunk and assign VLAN 99 as the native VLAN. We did that. Disable the generation of DTP frames. We did that. So now let's do that on switch number 2. And we'll get rid of, yeah, and there it is. And you can see spanning tree is blocking, which is why that port is orange. It's blocking the port right now because of the native VLAN mismatch. So let's get into enable. Into privilege exec with the enable command, and then into global config here. And we're doing the exact same thing, and I'm pretty sure that's going to be interface fast Ethernet 01, and I'm not going to, well, yeah, let's go ahead and shut it down just to make sure. So it is. So we'll say no shut, and we know what we need to do here, right? We need to say switch port mode trunk, or just, you could literally say SWMT for switch port mode trunk, because we're going to hard code it as a trunk port, set the mode to trunk. We're going to say switch port trunk native VLAN 99. This is going to get rid of the spanning tree issue, and it's no longer going to be blocking on that port. The port's going to be fine once they come up here and negotiate their spanning tree settings, and then disable switch port no negotiate. Now, you can see that the line is, or I'm sorry, the link is green on both ends. Do show interface trunk. And if I was to stretch this out a little bit so that it doesn't truncate, there we go, a little better to look at. So there we go. We can see that trunking mode is on because I said switch port mode trunk. The in cap is 802.1q because that is the default on newer equipment. ISL is not even an option anymore. My status, I'm trunking because we're up. The native VLAN is 99, and the port that is the trunk port is fast Ethernet 01. So this puts us at 21%, right? So we're in pretty good shape right now. We've got that set up. So let's go ahead now, and we're going to go beyond the DTP. So configure the switch 1 with the following port settings. Okay, so fast Ethernet 0, I'm sorry, I didn't want the PC up here. So we'll give the PC just a second to pop up, and then we'll get rid of it. So we want the switch. There we go. We want the switch. So let me get rid of the PC here. And again, the VM kind of slowing down on me a little bit. All right, so it looks like we're back. And that is not good. It got rid of, and let me see if I can undo this here. Oh, whoops, I'm sorry. All right, so we're going to pull switch 1 back up here. So do show interface trunk. And there we go. So everything looks good. So on switch 1, on interface fast Ethernet 06, it wanted us to do some work here. So it should only allow access mode. So how do we create an access port? So switch port mode access. And we're not tweaking the VLANs any. So typically I would say switch port access VLAN, and then whatever VLAN this port is in. But since it's in VLAN 1, and we're not messing with VLANs. Again, that's more of a routing and switching topic. Even if I said this, it's not going to show up in the running config, right? You see how fast Ethernet 06, it doesn't say switch port access VLAN 1 because that's the default. So again, remember, Cisco components 99.9% of the time, if it's the default setting and you type it in, it's not going to show up. And we'll see that with some port security settings as well. So we want to set port fast. So I'm going to say spanning tree, port fast, because it's a host port. We're going to skip the listening and learning states, go right from down to forwarding. And then I'm going to say, spanning tree, BPDU guard, enable. And let's make sure we've got that right. Set to port fast and enable BPDU guard. And we did that. That's good. The other one that you would set here is spanning tree guard root. Now, I'm not going to do it because I don't want to tweak the scoring engine here. I know it's sensitive already with this 98% thing that we found, but we're going to leave it the way it is. So fast Ethernet 06 uses basic default port security with dynamically learned MAC addresses added to the running configuration. This added to the running config, that's the important part. So I first have to turn on switch port security. Remember, if I don't type in switch port security, then none of the port security commands I enter in after this are going to matter. I have to enter that by itself. And then switch port security, MAC address, MAC address, sticky. This is dynamically learning the MAC addresses and adding them to the running config. So now when I say do show run, we don't see a MAC address in here yet. What if well, actually we don't have any IP set up yet. So we will at some point, we don't right now, but as soon as I generate a frame, a layer 2 frame off the PC connected to this port, we will see that. Now, all other ports should be disabled. Here is where knowing the range command becomes critical. So do show IP interface brief. I think it's 24 and then the 2 gig ports, but let's check it out. Yeah, so it's a 24 port switch. We've got the 2 gig ports. The only 2 ports that we are using are 6 and 1. So here's how we're going to do this and save ourselves a whole lot of time. So interface range, fast Ethernet 02 to 5, comma, right? Because remember, 6 is being used. Fast Ethernet 07 to 24, comma, gigabit Ethernet 01 to 2. Now, that may seem like a lot, but trust me, if you had to manually go in and do this, you might be here all day. And we're going to say shut down. And that's it. And that shuts down all those points. And I think that was only worth a single point. So definitely want to use the range command to save yourself some time there. All other ports should be disabled. Now, although not all ports are checked, your instructor may want to verify that all unused ports are disabled. And I do look at your running config on each of the components. All right, so we're going to configure AAA, but we're going to go back over here to router 1. So we waited long enough. The timeout expired, so I've got to get logged in. So Cisco con PA 55, and that puts me back at user exec mode. Remember, I'm coming into the console port here. So here I am in user exec. Let's type in the enable command to get to privilege exec, and the password is Cisco, and it was ENAPA55. And there we go. We've got the enable command in here. The privilege exec command has been entered in to get us into privilege exec mode. Now I'm reading up here. I got to squint because it's a little further away. Configure the following on router 1. Create a local user account. All right, so let's get into global config. So we're going to say username. Now here's where, okay, great. It says secret password, because I was going to say sometimes they say with password admin01PA55, and then you say username password, right? And it doesn't give you the points because it wanted secret. But here it's very clear it's going to be secret. So capital A, admin01, and then the secret, oh, it wants a privilege level set as well. So we're going to say privilege 15 secret, and the secret is admin01PA55. Now we're at 28%. The needle should move here if I did that correctly. And it does. All right. So again, little commands that we typically ran into issues with, we want to make sure we keep our eye on. So enable AAA services. Well, how did we do that? We said AAA new model, right? Because again, the old model of AAA is simply using the line passwords. This is the new model of AAA. So we're going to say AAA new model, and just like the switch port security by itself, we have to say AAA new model by itself. Now we've enabled AAA service, so it says implement AAA services using the local database, right? So we're going to be referring to the running config, and that's where that admin01PA55 comes into play. So implement AAA service. So we're going to say AAA authentication, because that's what we're using here. Now it wants the local database as the first option, and then the enable password as a backup. So for logging in, we're going to use the local, right? The default that we're going to use the local and then the enable. And there are, on real Cisco devices, there's other options, right? We can make it case sensitive. We could refer to a AAA group, things like that. So we're going to use default local enable, and the needle should move here. Now, based on that command, still, we haven't applied the AAA settings anywhere. So as of right now, right? We haven't put them on the console line. We haven't put them on the VTY line. We simply just did this, and that was it. And that's all it's asking for on router 1, which is interesting. So, and that's going to cover all lines. So it looks like the console line is all we're going to be, or actually, I'm sorry, by default, it's covering all of the lines. So because we didn't do a specific one. Again, I'm just reading again, making sure we've got everything covered. Yeah, so this is going to be applying to all lines by default. All right, so now we're going to configure SSH, and we're staying on router 1. Now, we're going to configure the domain name. So IP domain name is going to be ccnasecurity.com. And remember, for the activity, we need the domain name, but in reality, we don't need the domain name when we're getting ready to configure the SSH keys. We can do a label and avoid the domain name, but typically you see the domain name being used. So now I'm going to be able to say RSA key. So crypto key, generate RSA, RSA, and let's see if it'll let me put in, okay, no. So realistically, I would be able to say modulus and put in the key length, but here on Packet Tracer, I've got to say crypto key, generate RSA, hit enter, and now I've got to put in the 1024-bit key. All right, so SSH has been enabled, but it's SSH version 199. Very exploitable. Lots and lots of script kits that are out there to exploit SSH 199. So as is evidenced here in the activity, we're going to say SSH version, and it should, version, doesn't like that. SSH, it should allow me to, and am I missing something here? Only allow SSH version 2. Only SSH is allowed on the VTY lines. And so on router 1, SSH do show run. Interesting that it is not allowing me. That is definitely the command. And it's not from privilege exec. conft. So this is interesting. It says only SSH. Did I forget something? All right, hold on one second here. And you can see, it looks like in the activity that these have gone away. That we've lost our connections here between the switch and the router. And I'm wondering, all right, let me do this. Let's go ahead and say end, write mem, and show run. And let's make sure. Yeah, those SSH commands aren't in here, and it should simply be SSH version 2. All right, let's check router 2 real quickly here. So Cisco con PA55, CISCO CON PA55. It doesn't like that. Let's try Cisco ENPA55. Oh, I'm sorry. I'm on router 2. So it's Cisco ENAPA55. Apologize there. Get into global config, SSH, and it doesn't like that command either. So that's interesting that it doesn't like that command, because that is the command. In fact, let me, whoops, had to kill an application there earlier. And so let me pull up a switch real quick here. And we're going to go set OK. So what I'm doing right now is I'm going to a real Cisco, it's a 3560 with 15 code, and I'm telling you, oh, it's IP. I apologize. Boy, what a catastrophe. So it's IPSSH. It just dawned on me as I was IPSSH version 2. So there we go. So it's IPSSH version 2 and allow SSH only on the VTY line. So line VTY 0 to 15. And we're going to say transport input SSH and transport output SSH. I apologize about that. Boy, what an epic, yeah, and goes to prove that I don't have the answers in front of me, that I was under the impression, I just had it in my head that it was SSH version 2 for whatever reason. All right, so we've got that sorted out. I apologize there for that little snafu. And now we're back over here. And now let's verify that PCC can remotely access router 1 using SSH. But we've got to fix a few things here, right? Because for whatever reason, these connections went away. So the first thing I need to do is come on to router 3, because we've got to find out what those connections were. Well, we can clearly see it's going to be serial 001 and gig 01. So I'm going to come to my lightning bolt here. I'm going to click on the lightning bolt because it's going to give me the connections tab. I'm going to grab a straight through cable, and I'm going to guess that that was fast Ethernet 01 coming up to gigabit 01. We're going to put that back, and that looks like it could be, this could be correct, right? And then we've got the serial connection that I needed to have, which was from serial 001 up here to, and I don't know what it was. I'm hoping that's the only one that's available. And there we go. Green lights were up. So hopefully that fixed it. We're going to find out real quickly if it didn't. And again, because that was as a result of my VM kind of being a little slow when I went to kick open one of the PCs. So we should be good. Okay, we're green lights all the way through. And now let's check. The first thing I'm going to do is I'm going to ping, right? So let me see if I can ping over to 209.165.200.233. All right, so that's fantastic news right there. I can reach all the way over to router 1. In fact, I believe it's that interface. Yeah, it's got to be this interface here on router 1. So now the big question, can we SSH as the user admin01 to 209.165.200.233? And we can. So this should be Cisco VTY PA55. I thought that was the password. Let me double check. Oh, I'm sorry, admin. So the password is going to be ADMIN01PA55. And we are on router 1. And as you can see, the default AAA policy that we had configured, because it was the default, we didn't have to create a special name and then apply it to the VTY lines. It simply applies to all lines on the router. So that is working. So good news there. And let's go ahead and come back to securing against login attacks. So back over onto router 1. We'll hop off the VTY lines there. So if a user fails to log in twice within and I know that this is login, right? So here we go. Within a 30-second time span, disable logins for 1 minute. So login, I am going to block for how long? I'm going to block for 30 seconds. How many failed attempts is it going to take to trigger it? And I think it said 2, twice. Oh, I'm sorry, block 4, I got this backwards, for 1 minute. So 60 period in seconds. So for 60 seconds, attempts is going to be, let me check that again, 2 after within a 30-second time span. There we go. All right, so log in, block for 60, so block for 1 minute, attempts 2, right? 2 failed attempts within 30 seconds, and that should definitely move the needle from 35 to at least, oh, look at that, we got 5% for that, so to 40. Now we're going to log all failed attempts. So log in on failure, and actually we want to do log in on failure log, right? And let me make sure, and yeah, that moved the needle. So log all failed login attempts. If I wanted to log all successful attempts, I would say on success log as well. So we're going to say login on failure log. If I wanted to trap it, right, and send it to a syslog server, or create an SNMP trap, I could use trap as well. So we're at 41. Now we're going to get into sort of the meat here of the activity. That kind of brings us all the way up to about week 6. So now we get into sort of the hardcore settings here, and this is the more difficult part of the activity. So we've got site-to-site IPsec VPNs, well, VPN we're going to set up here. We've got zone-based policy firewall and IPS settings that we're going to be doing. And then we're going to get on to the ASA firewall. All right, so let's go ahead and get our IPsec VPN on. And this is going to be, I'm reading here real quickly. So it's got to be between 1 and 3 is my guess. Yeah. Okay. So we are pretending here that this network out here, this loopback interface that's out here, that's going to be the IPsec tunnel. So it's going to be a tunnel that runs from basically, it's going to encrypt the traffic that is destined this direction between these two networks, right? So we've got our firewall here. But instead of doing that site-to-site, right, we've got the firewall, we're going to do it from out here. So we're basically saying that maybe this is, you know, a branch office of some kind that we're simulating with a loopback address. Remember, a loopback address is nothing more than a software virtual IP address that allows us to simulate networks, right? It also allows, it's a great idea to use if you're managing the device. A lot of devices are managed via a loopback interface, because the loopback interface is never down. So let's go ahead and let's sort this out here. So just like we did, some VPN configurations are not scored. However, you should be able to verify connectivity across the IPsec tunnel, and we know how to do that. So enable the security technology package license on router 1. This is the most important step, because if you don't do this, nothing else we do on router 1 from a security perspective, we're not going to be able to do it, right? So how do we do that? Well, we say license module or license boot module C1900 technology package security K9. Now, if I say do show version, are we going to see that the security license is there? Now, it says evaluation, right? Because I just typed the command in. However, we should have to, yeah, save the running config. And this is the step that a number of you ran into issues with throughout the term here, was it's not good enough just to say license boot module C1900 technology package security K9. We have to save the config and we have to reload the router. And very important to save your configuration, because if you didn't save your configuration and you reloaded, you would see the score. You see how it transitioned to 30 here? The completion percentage is at 30. Well, when the router comes up, look, it bumped me back to 41. If you didn't save your config and you reloaded, you just lost everything. It would have stayed at 30. So here we are. We're back up. Okay, username. So admin 01, and it should be admin 01PA55. All right, so here we are in user exec mode. I type enable to get into privilege exec, and this is Cisco ENAPA55. They changed that password up on us just a little bit. So now we are set. So let me scroll down just a little further here. I think that this is going to do it, that the activity bottoms out. So we are now sort of in the home stretch of the activity, so to speak. So configure the following on router 1. Create an access list to identify interesting traffic. Now remember, we're using crypto maps here, right? Not the new way to do it, which would be an SVTI, or one of the new ways to do it. An SVTI is static virtual tunnel interface. So I need to identify the interesting traffic, because on router 1, I need to let it know how to differentiate traffic that should be encrypted based on source and destination IP information, and traffic that shouldn't be encrypted, traffic that we should just go ahead and let flow out of the whatever serial interface this is here, out of that serial interface unencrypted. So let's get into global config and the interesting traffic. So, and actually, let me see. Okay, ACL 101. So I'm going to make sure I follow along here. So it's going to be access list 101, and we're going to permit, and it's going to be IP, right? It's not TCP, it's not UDP, we're permitting IP because that matches everything. Now, coming from 172.20.1.0, and remember, this is a wildcard mask in the ACL. The 0.0.0.255 is the wildcard mask in the ACL. Going to what network? Well, it's this 172, if I bring this down just a skosh, it's going to be this network here, which is where router 3, which is where router 3 is at, but more importantly, where PC3 sits behind and is in this network. So 172.30.3.0, and then again a wildcard mask 0.0.0.255 because it's /24. So very straightforward, right? Super easy to do. We throw the extended ACL in. We put the IP as the protocol to match all traffic. So we're saying right here is match, with the permit, match all traffic going between the 172.20.1.0/24 subnet and the 172.30.3.0/24 subnet. And we're going to encrypt that traffic. And we're going to do the encryption component right now. So configure the crypto ISACAMP policy. And again, they kind of, this is kind of nice here, right? They make it not too difficult by making you remember everything. So crypto ISACAMP policy 10. So, and again, remember, when we're talking about ISACAMP and IKE, right? It's ISACAMP / IKE phase 1. Those, we're talking synonymous with those terms. ISACAMP and IKE phase 1, and then ISACAMP and IKE phase 2. If you say it's the same thing, just think phase 1 and phase 2. You can say IKE or ISACAMP phase 1. You can say IKE or ISACAMP phase 2. We're talking about the same thing. Where it's different is where you're saying IKE version 1 and IKE version 2. Those are different, right? But in terms of the phases, ICE and ISACAMP, we can use them interchangeably, and you'll hear people use them interchangeably. All right, so we're going to protect the keying material. Let me get back up here. Properties on R1 that are shared with the crypto. Okay, so we're going to use pre-shared keys, and we've got that password. We've seen that before. So what can we set here? Well, first thing right away, authentication, I can do pre-share. And then we're going to set the encryption to AES. Now it says set it to AES 256. So I say encryption AES 256. If I were to say do show run, real briefly here, it shows up in our config because I believe the default was 128 maybe. I can't remember the default, but it does show up here. So the hash that we're going to use, right? So I'm going to say hash is SHA. And then the authentication method, we did that already. Key distribution method is ISACAMP. And then the Diffie-Hellman group. So we're going to say group 5, and I'm trying to pay very close attention here because if this gets screwed up, it's going to make troubleshooting brutal. All right, we're going to set the lifetime to 3,600 seconds. Before the key material is renewed. And then we've got our pre-shared key. So we took care of the authentication, the encryption, the group, the hash, the lifetime. So we should be good. The key distribution method, ISACAMP. It's interesting that they put that up there. All right, so let's exit out. And now we're going to say crypto ISACAMP. And this is how we're doing the keys here. So crypto ISACAMP key for the pre-shared key is going to be, and now this gets very curious because I don't see how they want us to do it. They want us to use the exact IP on the outside. Now, we'll stick with what they use. And again, it says some of the stuff isn't scored, so this might make it a little difficult here. So we're going to say crypto ISACAMP key, and the key is Cisco VPN PA55. Now this is the part that I'm wondering about because you can't put quad zeros. Now previous packet tracer activities that we've done have had us put in the exact IP, and I think that is what I'm going to do here. Let's get to the addressing table. It's going to be from that router interface right there to this router interface right here. So what is the peer IP address right there on serial router 3001? 10.20.21. And so I'm confident 10.20.20.1 that is what they're looking for. Now we're at 48%. If the router gods are being kind, it'll show, oh, sorry, and I needed to put in here, I think it's peer. PA55, address, yeah, address, and 10.20.20.1. Again, if the router gods and the subnet mask, we shouldn't have to, if it's a /30, if we're using a host IP, we don't need the all 255s, and are we? Yeah, we do get 2 points for that. So very kind right there that we're able to validate that that was what they were looking for from an addressing perspective, right? And that we don't need, when we're using a /32, you don't need to put the all 255s. Excuse me. Okay, so we're good there. Let's come all the way back down here. On router 1, we did that. And we did all of the settings here. So now we're going to go into, and again, we're going to have to do this exact same thing again on router 3. But for right now, we're going to stick with, we're going to stick with router 1. So that's phase 1, right? That is my IKE/and/or ISACAMP phase 1 settings. That's going to protect the keying material that the routers are going to be exchanging in order to set up the phase 2 IPsec tunnel. And that's what we're at here. The transform set is our phase 2, our IKE/and/or ISACAMP phase 2 settings that give us the IPsec tunnel. So let's go ahead and do transform set. And why is that giving me, oh, I'm sorry, forgot to, again, left off the crypto. So crypto transform set, IPsec, I'm totally blowing it here. Crypto IPsec transform set by forgetting some of the keywords. Create the, because I'm reading and trying to get this typed in. So create the transform set, VPN set. So VPN-set to use ESP, whoops, sorry, not ESPN or ESPC, ESP-AES 256, which may be the default, but we're going to type it in anyway, and then ESP SHA -HMAC. So remember, what's the difference? If we only used AH, authentication header, we wouldn't be able to do NAT, right? Not only that, with AH, you can't do encryption, right? We can't encrypt. So we can provide the authenticity, but we could never provide the confidentiality with AH, which is why we use, and I did ESPC again, which is why we use ESP, encapsulating security payload, or sometimes you'll hear it as encapsulating security protocol, because ESP can do both the authenticity and the confidentiality. It can provide the encryption that we need, and that's what we want, which is typically why you never see, and it supports NAT, which is typically why you never see AH being used. It's usually always ESP. Excuse me. Okay, we hit enter. Remember, we don't see what here? The mode. Right? So by default, we're using that tunnel mode, which is going to give us an outer header. So we are set there. So create the transform set, VPN set to use AES and ESP-HMAC5. Then create the crypto map. So crypto map, and it's going to be called CMAP. Now it's a key here at the end. When I say crypto map CMAP, I want to say ISACAMP, whoops, ISAKMP. And let me make sure I get this, that binds all the phase 2 parameters together, use a sequence number of 10, whoops, sorry, sequence number of 10, and IPsec ISACAMP. So there we go, and identify it as an IPsec ISACAMP map, use the following parameters. So here's where we kind of pull everything together, because the map, think of it as the guide for the router to figure out, hey, where do I find the interesting traffic? Hey, what transform set am I supposed to be using? You know, hey, perfect forward secrecy, right? And this is also key because this protects the rekey component. All right, so do a question mark here. You can see we could put a description in. It's not calling for that, so we're going to leave that out. So I'm going to say set my transform set. I'm making sure we get the right. So VPN-set. I'm going to set transform authentication. So hold on one second here. So we actually need, they've actually added in some other things here. So we're going to set the transform set to VPN set. Transform encryption. So that's already been done. And we're going to set perfect forward secrecy to group 5, group 5. And we're going to set, and no, they don't have no lifetime here. So let me read this. Let me make sure I've got this right. So the transform encryption is good. IPsec ISACamp is good. Bind it to the outgoing interface. So I'm sorry, I'm rereading this here to make sure I get this right. So we've got the transform set done, and we need to set the peer, right? Because that's going to be a key component. So the IP address. Now this is again going to be the 10.20.20.1. It's going to match what we used when we set our pre-shared key up. Set peer, and I'm just, again, I want to double check here and make sure that we've got all of this done. IPsec ISACamp. Okay, so that should be, for the map, that should be it. Peer PFS transform set. Yeah, we should be good with the map. So now we're going to bind it. So I'm going to jump onto, and well, actually I'm going to say do show IP interface brief. Let's see which interface we're probably dealing with here. And it's going to be serial 000, right? So interface serial 00, and I'm going to say crypto map. And did I call that to show run? Did I use the wrong name? Okay, CMAP, I didn't. All right, so crypto map, I thought I may have used VPN set. So crypto map CMAP, and what do we have to say? That's it. Crypto map CMAP, hit enter, and we can see that ISACamp is on. Now, the tunnel is not going to come up. Why? Yeah, we need to verify the security technology package license is enabled and repeat exactly what we just did over on router 3. So the configuration needs to mirror what we've done on router 1. So let's pull router 3 into the fold, and I'm going to move through this in a little more expeditious fashion here since we've done it one time. We'll get into global config, and we're going to say crypto ISACamp policy 10, and I need to relook at these. So we're going to say authentication is going to be pre-share. We're going to set the encryption to AES 256, and we're going to set the hash to SHA. We're going to set the group to 5. We're going to set the lifetime, which we didn't do in the regular activity, to 3600, and that should be it. We've got the authentication set, the encryption is set, the group is set, the hash is set, the lifetime is set. So now let's go ahead and set the pre-shared key up. So crypto ISACamp key is going to be, and don't mess this up, Cisco VPN PA55 with, and now we need the address of router 1's serial interface. So let me come back up here to router 1, and it's 10.10.10.1. So let's go with 10.10.10.1. And again, you don't need to put the all 255s in there because that's the default. So there's our phase 1, our ISACamp phase 1 settings. We're done. Now let's get in here and say crypto IPsec transform set VPN set. We're going to do ESP-AES 256 and ESP-SHA-HMAC. And let me make sure that is it. And then we're going to do our crypto map. So crypto map is CMAP. And we're going to use, what policy number did we use? Did I use, okay, sequence number 10, there we go. And then IPsec ISACamp to identify it as an IPsec ISACamp map. So here we are, we're in here. We don't need the description, so we're going to set the well, actually, let's do this in order. Yeah, so set transform set to VPN-set. We're going to set our PFS to group 5. And we're going to set the peer, and it's interesting, they kind of leave that out there. So 10.10.10.1 is our peer, and that should be everything we need. The peer, the PFS, the transform set. So now I'm going to jump into serial 001, and we're going to say crypto map CMAP. And you know what we didn't do? What step did I skip? Exactly. I left out the ACL. So access list 101 permit IP 172.30.3.0.0.0.255 going to 172. And I'm sorry, was that a 172 over there? Yeah, to 20. 172.20.1.0.0.0.255. Yeah, because I didn't match the in fact, I didn't match the access list on either side. Access list one, oops, sorry, I got an extra list in there. Access list 101 permit. So now what do we need to do? We need to go back into the crypto map CMAP 10 and say match address 101. Definitely not that. 101. So do show run. I forgot to put the map in there. Let's make sure we're good. Match address 101. So end, right mem. Let's go do the same thing on router 1, right? What did I forget with the crypto map? So let's exit out here and let's get into the crypto map CMAP 10, and we're going to match address 101. So forgot to do that initially. Let's save our configs here. Now, hopefully, that did not just blow the scoring engine up. So ping the loopback interface on router 1 from PCC. So let me come over here to PCC. Let's get our command line up, or the command prompt up, and let's ping 172.20.1.1. And with any luck here, hopefully I'm not going to have to pull the crypto maps off. Thank goodness that that worked. All right, so... All right, and they just want us to do a show crypto IPsec here. So if I was to take a look on router 1, show crypto, whoops, show crypto IPsec security association, SA, right? And there are the packets, right? So our site-to-site IPsec VPN tunnel has been set up, albeit missing the access list application in the crypto map there briefly, but sorted it out, right? And we recovered gracefully, and it is working. So configure firewall and IPS settings. Now, again, we're talking about a zone-based policy firewall here. Remember, you have to have the security license applied for the zone-based policy firewall as well. So we did it for the site-to-site, and that's great, right? But we would also need it if we weren't doing site-to-site, and all we were doing was zone-based policy firewall. We still need that security K9 license. All right, so we're going to do it on router 3. Now, brief architectural discussion. Why does it make sense to do it on router 3? Yeah, so we've got the firewall here protecting our inside network, right? And let's look at it like this. And we kind of have been looking at it like this. And let me get my pen. The mouse is not too good to draw with. So think of it like this. Here is this branch. We'll say it's branch 3. And maybe this is in New York City, right? So we've got the IPsec tunnel set up because when it's communicating with, in this loopback address, again, they didn't put all of this over here, which is fine, but let's say that this is branch 1. This was our first branch, and this was in San Francisco. And then here's my headquarters facility. Whoops. Here's my HQ facility, and let's say that this is in Crofton, Maryland, which is where I'm at. So Crofton, Maryland. Right? And so we've got an IPsec tunnel that's encrypting the traffic between these guys because maybe we couldn't afford to put a firewall out here, right? So of course we would probably do zone-based policy firewall here if that's what we were doing. And router 2 is nothing more than the ISP, right? And so we're going to do zone-based policy firewall over here on router 3 because we couldn't afford a firewall over here either. Right? Headquarters was the only place we could do that. So we're growing slowly. And maybe this makes sense, right? It's, remember, use case, use case, use case. It's all about the use case. And for a branch office, that doesn't have power or doesn't have space or heating or cooling or whatever the case may be to dump another firewall in here, we can achieve the exact same thing that we need to with that IPsec tunnel and zone-based policy firewall. In fact, I think, if I'm not mistaken, yeah, we're going to configure intrusion prevention on router 3. Why not, right? Because we can have zone-based policy firewall and intrusion prevention, and we've got this IPsec tunnel. All right, so let's clear the screen here. Let's get back into command mode on router 3, give ourselves a little more room here without covering up any interesting stuff. The signature files are already imported and in place. Remember, refer to the previous video that I did, that tutorial, the supplement where I configured iOS IPS on a real Cisco router, because there's some steps that we're not going to see that are going to be required to get that up and working. Okay, so well, I'll just show version here. So show version, we should see that we've got the evaluation license for Security K9. We've already applied it because we've got the crypto map on here. I don't remember if we reloaded this router. So this was something that a few of you ran into, where you would come into global config here and you would say, and what are we supposed to do here? Create zones named in zone and out zone. So I'm going to say zone, and if you did a question mark, you wouldn't see anything. And that's because you either haven't applied the license, the security license, or you applied the security license, but you didn't remember to reload the router. So how about zone security? And it's just going to be in zone. And we might as well do the other one, which is going to be zone security. Whoops, sorry. Zone all right. Zone security out zone. So inside zone, outside zone, out dash zone. Now, there in the class map, we're not going to be matching protocols per se. We're going to be referencing an ACL. So let me make sure I remember to get this done. So create a class map named internal-class-map that uses the match all option and ACL 110. Now, here's the thing, is they didn't tell us. So they're not giving us the information that they're looking for in ACL 110. So if it's match all, let's try this access list 110, we're going to permit IP. So here's what we're going to say. So we're going to go with 172.30.3.0, 0.0.0.255. So I'm going to match everything coming from, now, and remember, it's almost counterintuitive. So this is what I'm going to do, and this has got to be correct. They don't say, because they want match all, so it's got to be all traffic. So it's kind of counterintuitive when you think about it. We break the ACL down. So access list, and it's an extended ACL numbered 110. We're going to permit. In other words, we're matching the traffic that we want the firewall, the zone-based policy firewall, to inspect. And we say all by saying IP here, right? Because that's all types of traffic coming from that subnet going anywhere. And the reason it's kind of counterintuitive is that saying traffic from the PC3 or PCC down here, when it comes into the router, right, it's matching traffic from our LAN segment down here that's covered up right now, this LAN down here with PCC, and going anywhere. Because remember, what is the zone-based policy firewall doing? Yes, it's creating that stateful entry on the router so that when the return traffic comes back, that it says, oh yeah, I've got an entry here in my state table that tells me that I match the traffic going out from that LAN segment going anywhere. Therefore, I'm going to have a session. I happen to have a session here that says for all the return traffic coming back, we're good to go. And I'm going to allow that traffic to flow back through. So again, it's almost kind of backwards in a sense, but when you think about it logically as to what the router is doing when it matches that traffic, that's the behavior that we would expect to see. And then I'm going to go ahead and I'm going to say, and I'm going to go on a limb here, and let's see if they're scoring this. access list 110, deny, IP any, right? So there's an implicit deny IP any at the end, but as I'm looking at this, I'm thinking to myself, are they scoring this? So the completion percentage is at 65. I'm going to hit enter, and interesting, it dropped it to 64. So let's say no access list 110. And does that move it up back to 65? So that's interesting. It dropped my completion percentage from 65 to 64. So there's access list. Oh. And did it actually remove? Let me see what just went down there. Hold on one second here. I'm trying to find the ACLs. If I'm not mistaken, that just removed the ACL. All right, so let's do this. So we're going to say, we'll come back at it again. So access list 110, permit IP from 172.30.3.0.0.0.255 going anywhere. Does that get me to 65? That is interesting. Okay, so they definitely, it does not appear that they want you to put in deny IP anything. Again, it's implicit, it's there. We're not going to see it, but it's there. It's an implicit rule at the end of every ACL is that deny any. But I thought they may want us to type it in because I could have sworn that in one of the activities we did that, but we'll leave that where it is. Okay. Oh, and here it is. I completely missed that, to any destination network. So there we go. So we've got it. Now we're going to create a class map named internal-class-map. So we say class map, again, using this QoS-like syntax, we're going to say class map type inspect, and we have to say inspect, right? Let me pull this back, class map type inspect, because if we don't say inspect, it's going to think it's a QoS map that we're trying to create. Now, do we want to match all or match any, right? And remember, the difference is it's a logical and when I say match all, which means if I put multiple match criteria, it would have to match all of them. If I say match any, it's a logical or, which would mean match TCP or UDP or whatever it is that we were putting in there. Or it could be, match ACL 101 or ACL 102 with match any. So, but what we want to do is and let me double check, we want a match all. And that is our default, is match all, internal class map that uses the match all option and ACL 110. Class map, and I can get the name right here, this name, internal class map. And that should be match access group, match access group. I was going to say match address. Match access group 110. Create a class map named internal class map that uses the match all option ACL 110. All right, so we're good there. Now we're going to create the policy map that we would use. So we come back out and we say policy map, again, type inspect, and now I get down to these names that they're choosing, in-2-out -pmap for policy map in-2-out that uses the class map internal-class-map to inspect all traffic. Class type inspect, and this is going to be internal, boy oh boy, internal-class-map to inspect all traffic, internal-class-map. And what are we going to do? We're going to inspect. And so no specific protocol configured in class map, internal class map for inspection. All protocols will be inspected, and that's okay. We've got that ACL in there. Now we're going to create a zone pair. All right, so let's get out of the policy map configuration. So we're going to say zone pair, because now we're going to match up the inside zone and the outside zone. Zone pair security. Whoops, let me make sure I'm right there. Whoops. Yeah, zone pair security. Now, name of the zone pair. What is this name? They've got a screen here. In-2-out-ZPAIR. That identifies in zone as a source zone, out zone as a source zone, zone pair. Okay, so source is going to be in zone, and remember that the destination is going to be the out zone. And those were the zones. Remember, initially we created those with the zone security in zone, zone security out zone. We've added those in here, and now I'm still reading along, and I think we are good. We now need the service policy. So what service policy is going to be associated with that? So service policy, remember, type inspect. Remember, inspect, inspect, inspect. And now the policy name, specify that the in-to-out PMAP, in-to-out-PMAP, make sure I got that right, is used to inspect all traffic between the zones. And that should be it. Okay, so that should be it for my zone pairing. And hopefully I didn't forget anything. All right, so now what are we going to do? We're going to interface gigabit Ethernet 01, which is probably, I think we used that before. Let me double check real quick here. Router 3, yeah, gig 01. Okay, so we're going to go down here to interface gigabit Ethernet 01, and now we're going to go ahead and make the interfaces members of their respective zones. So I'm going to say zone member security, and is this the inside or the outside on the gigabit interface facing the LAN? Yeah, this is the in zone, right? So zone member security inside zone, and then we're going to go into interface serial 001, and we're going to say zone member security out zone. So zone member security in zone, zone member security out zone. And do we get any points for that? We do. We picked up a single point for that. So that should be it. Okay, wait, sorry. Yeah, and then configure the IPS on router 3. All right, so we're not done yet. So we're going to do the IPS configuration on router 3. Again, a monster activity here to wrap things up, but definitely some really, really good stuff. And where did we leave off here? It says configure an IPS with the following requirements. So that is what we're shooting for right there. Now, a lot of things are already done, and I'm prepping here. Okay, within the packet tracer, the routers already have signature files, XML, configure public crypto key. Okay, so we're going to create the directory named IPS-dir. So that's just make dir, mkdir, and then it's going to be called IPS-dir. Now, we're going to set that as the location for the signature file. So after we make the directory, and how do I see that? I could simply type dir, and there's the IPS-dir. I could say dir IPS-dir, and we'll see that it's empty. You can see that Packet Tracer's kind of pre-staged a few things there for us. And the directory is empty. We don't have anything in there. So let's get into global config. Let's say IPS config location is /IPS-dir. Yeah. Oh, you know what? Let me make sure I got that right, because I misspelled it in that command. Do dir IPS-dir. So if I was to say dir IPS-dir, do dir IPS-dir, yeah, it comes back and says file not found, because again, it's empty IPS-dir, but it's there. So IPS location, or I'm sorry, config location, and we're going to say /IPS-dir. And that should get me at least a point, I would think. All right, no points. Let me double check and make sure I've got this right. IPS-dir, do dir, IPS-dir. Okay, so we should be good, although we didn't get a point. Not everything's scored. So, okay, so let's continue to move forward. So we're going to create a rule. So IPS rule, or I'm sorry, name is going to be IPS-rule, and retire the all signature. So IPS signature category You have to type signature out. Signature category, we're going to go to category all, and then we're going to say retired true. And remember the difference between retired and unretired, right? Okay, so let me read this again. Retire the all signature category. All signature with the release. So we did that. And now we're going to unretire the iOS category, iOS IPS, and that should be, no, wait, what did I miss there? Unretire the iOS IPS basic with the retired false command. So I'm in the category. I think I'm going to back out one more. Hold on a second. That is definitely not what I wanted to do. So let's try this again. So IPS, signature, category, and I wanted category all, retired true. And then from there, I simply wanted to go to, is there not a category? Was I misspelling category? Oh, iOS underscore IPS. I apologize. So got that totally wrong. iOS underscore IPS basic. As you can see, I've actually lost some of them. Retired is going to be false, and hopefully this doesn't blow the scoring engine up on us. Exit, confirm. So we are at 85, and I don't know if that's going to get us any more. Apply the rule inbound on the serial 001 interface. And again, doing this from memory is not easy. Serial 001 interface, serial 001 interface. And we're simply going to say IPS, and I think it's the name of the rule, IPS-rule, and what direction, right? So now we've got to think about directionality here. So it's on the outside serial interface, and we want to inspect the traffic that's coming into the environment. So we would say IPS rule in, and I think we got 1% for that. So now we're at 86%, and the engine builds have all wrapped up. Let me go ahead and say right memory. If I'm not mistaken, we are now in. We can see the finish line, the final stretch here. We're going to configure ASA basic security and firewall settings. And as promised, we should end up at 98% if I do everything by the book here. All right, so let me pull this down. We're going to get the firewall up here. We haven't touched the firewall yet. It's kind of our first foray into configuring our firewall. So here we are on the ASA firewall. Let's go from user exec into privilege exec with the enable command. Remember, by default, there is no password. You simply hit enter. All right, let's get into global config, and for interface VLAN 1. And actually, before I configure anything, it says that some of the things are set, and at least says some of the things were set. So as you can see, interface 00 is already a member of VLAN 2. Take a look at this. The VLAN 1 is already named inside. The security level is already set. VLAN 2 is named outside. The security level is already set. No IP addressing. And there's that command, IP address DHCP. If you were setting up a firewall and you connected it to your service provider, that is the command that you would use on the outside interface to get a DHCP address from a Verizon, from a Comcast. Now, interesting, there's the SSH timeout set to 5. The Telnet timeout is set to 5. And that's it. DHCPD, just like the previous act, I think it was 9311, where lots of things were already set up and the scoring engine was kind of pre-canned, gave us a 2%. So let's do this and let's see what happens. So for the VLAN 1 interface, configure the addressing to use 192.168.10.1. So interface VLAN 1, and I am simply going to say IP address 192.168.10.1, 255.255.255.0. Let me double check that. That looks good. And then for VLAN 2, interface VLAN 2. Now this is interesting. It says remove the default DHCP setting and configure the addressing using that. So here's what I'm going to do. I'm going to say no IP address DHCP. Right now you can see it removed it. I don't know if it doesn't look like we've got a point for that, but the fact that it specifically said remove it. Now, did I have to do that? No, I could have said IP address 209.165. 200.234, and our 29 is going to be a 255, 255, 255, 248, right? A /29, where we've borrowed 5 of the address bits and made them network bits. And so that would be 128 plus 64 is 192, plus 32 is 224, plus 16 is 240, plus 8 is 248. Those are the 5 bits we've borrowed. And that should be it. I could have just typed that command by itself, but let's see. Do we get a point for that? We got 2 points for that. Okay. So they gave us 2 points for getting the IP on there. Now, we're going to configure the host name. And I'm reading here to see domain name, enable password. Okay, so let's set the host name up. So how do we do that? Very simple. This is kind of easy, right? CCNAS-ASA, as long as we type it correctly. Do I get anything for this? We get a point for that, right? So I get 1 percentage point for that. The domain name. Now, on the routers, we say IP domain name. On the firewall, we say domain name is CCNASECURITY.com. See if we get a point for that. Yes, we got a percentage point for that. So the enable mode password, so let's go ahead and say enable password. Remember, on the firewall, you don't say enable secret, you say enable password, but it still does the secret MD5 hash. And this is going to be Cisco ENPA 55, CISCO ENPA 55. And we've got the level and the encrypted. Does it give us any guidance there? It does not. Let's see. Do we move the needle to 93? All right. Doesn't look like we moved the needle, so it might simply be that there's no points for that. We'll keep that in mind. All right. Now, we're going to create a user. Admin PA 55. I'm just reading here to see what we're going to be doing with the user. Okay, so username admin. I'm sorry, yeah, username admin, password admin PA 55. Do not use the encrypted attribute. Configure a local user account name admin with the password admin PA 55. Do not encrypt that attribute, or don't use the encrypted attribute. And we didn't. And I think that moved the needle a point. Configure AAA to use the local ASA database for SSA authentication. Now remember, it's a little bit different here than on iOS. So we're going to say AAA authentication, SSH, and here's where you get this console word. Remember, this is not talking about the console port on the firewall, right? So SSH console, it's basically saying, you know, how do you want to do the authentication, right? And what we're going to say is we want to use the local, right? And I'm sorry. Oh, whoops. No, I don't want to do that. And please tell me. Okay, good. Make sure the scoring engine very sensitive here. Make sure that we do not blow this up. So we say SSH console, and then this is where we would say local, because I wanted to use the local AAA database. In other words, the running configuration file. And so we drop that in there. We end up picking up a point. And let me find my place again. I apologize. Configure AAA, use local database. Okay, good. Now, here's where it becomes interesting. This is where it says, allow SSH access from the outside with a timeout of 10 minutes. It says nothing about the inside. But the fact that we configured the username, allow SSH access, configure AAA, and use the AAA database. Oh, yeah. And use the AAA database for SSH user authentication. So here's where it gets a little dodgy, right? Where it doesn't say do anything with that 192.168. So let's do this. If I don't put the 192.168 in there, we're at 94% right now. Here's where I would type in this SSH 172.30.3.3 subnet mask of all 255s, and then outside, right? Because it doesn't say anything about 192.168.10. So I put this command in. Does it move the meter from 94? And I don't think it's going to. And then it wants SSH timeout 10. Now the default was 5 in the file. We put 10. Do we move the meter to 95? No, it stays at 94. So if you were doing this in order and walking through this activity, here's what's going to happen. And so my guess is we're going to unfortunately end up at 98. So DHCP settings. So assign IP addresses to inside DHCP clients from 192.168.10.5 to .30. And the default, I think, goes up to 36. So we're going to say DHCP D, and we're going to do address 10.5 dash 192.168.10.30. And on the inside, right? So the DHCP daemon is going to be running on the inside. That's the pool it's going to use. You take a look. We just got 2 points for doing that. So that pushed me to 96. Now, DHCPD enable, I think we don't get points for this because it's already done. In fact, let's check. Show run. Yeah, so you can see the DHCPD enable command on the inside is already there. But I'm going to put it in just to make sure that we don't miss out on points here. So we're at 96. I run the command. My guess is no points are going to come of this because it's already in there, and it looks like that's the case. Enable DHCPDB to listen for DHCP client requests. Okay, so configure static routing and NAT. So again, we need to tell the firewall how to go from the inside, or how to just basically what's our default static route out, right? So it's going to be route outside is going to be the quad zeros, and I'm having all kinds of issues typing this morning. 0.0.0.0 and then 0.0.0.0. And who is the address that we're going to be going to? 209.165.200. And what is router 1? 233. So that's the next hop address. So we're telling the firewall that any traffic that shows up here that you don't have a longer, more specific match for, hey, throw it out to router 1. Let router 1 deal with it. And that'll be 233. So 209.165.200.233. And that should be, let me reread that real quick. Static, create a static default route. The next hop router 1 IP address. Okay, so that's that for the outside route. Create a network object, right? Remember, everything is objects. So how do we create the network object? We just simply say object network, and we're going to do, and the name of it is going to be what? Inside-net. So we're going to be doing an inside-net object and assign the attributes to it using the subnet and NAT commands. So what is the subnet here on the inside? 192.168.10.0, and then we're going to use 255.255.255.0. Now we're not done yet, because remember, the natting gets done with the object. We're going to say NAT. When we go from the inside to the outside, we're going to be doing dynamic interface, which means, right, we're simply doing PAT. This is port address translation. And this same syntax will work if on the outside firewall interface I had on there IP address DHCP, right? Because this is just saying, hey, use PAT. So whatever that IP address is that we get for the outside interface, that's what I'm going to use for my port address translation, right? Or NAT overload. So let me reread this in NAT inside outside dynamic interface. So that looks good. And I wonder if we get a point for that from 97. Do we get any points? No love? Okay. So we're still at 97. We took care of the NAT. Now we are going to modify the Cisco modular policy framework. Now here's the thing. Oh, whoops. Didn't want to do that. Let's get back into global config. So here's the thing. The modular policy framework, there is a default modular policy framework on the ASA firewall. However, in Packet Tracer, you don't see it. It's not there. So we've got to run some commands here to kind of create one. And the first is going to be the class map, because again, it uses that modular quality of service sort of syntax. Okay, so we're going to say class map. I thought it was inspection. Oh, let me take a look. Yeah, class map and inspection. I'm not reading it right. Inspection default. So we're going to configure class map inspection default to match. So class map inspection default. And now we're going to say match, match, and we're going to match default dash inspection. Wait, is that an underscore? No, I'm sorry. Inspection traffic. Looking to the left and looking to the right. I keep losing my place here. Match default inspection traffic. DEFAULT inspection traffic. Just make sure everything's spelled right here. So we're at 98% right now, if you notice that. And my guess is, I'll be shocked if this dumps me at 100. It shouldn't. Okay, and then exit to global config mode. We did that. And now we're going to configure the policy map. So we're going to say policy map, and then these names are global, and this is the one that we would typically see, global underscore policy. And then we're going to enter the class inspection underscore default and enter the command to inspect ICMP. Then we're going to exit out. So I'm going to say class is inspection underscore default that we used above. And then I'm going to say inspect ICMP. And this is going to allow those pings to go through, and I'm on the ASA, so router 1 would, I'm sorry, router 1, the host behind the ASA here is going to be allowed to ping out. And we saw this in 9.3.1.1. And let's exit out, and then finally we're going to say service policy, service policy is going to be global underscore policy, and I'm going to apply it globally to all interfaces, right? So service policy global, let's see, does this give me 100%? And it doesn't. And so here is where, let me save our config. Does saving the config change things at all? It doesn't. Now, we walked through everything here, right? So these PCs, A and B, should be able to ping out, right, to different locations on the network. But I'm going to deal with this 98. So here we are at 98%. Now, what didn't we do? We didn't put in a management statement to be able to manage the firewall on the inside. So if I was to do that and say SSH 192.168.10.0, 255.255.0 inside, will this get me to 100%? And you'll notice it doesn't do that. Right? So we're stuck at 98, and this is where everyone is getting stuck. So when I come to check results, and I come in here, and I look, I see, well, take a look at that. I've got 93 out of 94 things done correctly. Everything is green except the access setting, right? And so one of the things you might have done is to put those things in there, thinking, and you see that, right? And from 9.3.1.1, we kind of had a similar issue. So you see the SSH statement, you know it's for the outside, maybe you troubleshoot it, and the reason I knew to put the 192.168 in there is because the first learner, Louis, who sent me his activity, he had that in there, and I thought, well, that's a creative way to troubleshoot, right? Let's put that in there and see what happens. And so that's where I started tinkering with things. And again, no matter what I did, let's watch what happens here. When I say no SSH 192.168.10.0, 255.255.255.0 inside, I say no SSH 172.16, I'm sorry, 172.30.3.3, 255.255.255.255 outside, and then I say no SSH timeout 10. You'll notice that not only does it not give me points for taking any, it doesn't take any points away when I do that, which leads you to believe that it's something else. So now let's do this again. What if I was to say SSH, and I'll enter these in individually, 192.168.10.0, 255.255.255.0 inside, SSH 172, and I'm putting them in, this is a different order than they went in with the activity initially. 30.3.3, 255.255.255 outside, and then I say SSH timeout 10. And of course, we get different behavior. Take a look at that. So then the completion percentage moves to 100. When I troubleshot this the other day, it did not do that. It left it at 0. It forced me to cut and paste the values in there. So this is, whoops, sorry. This is absolutely incredible. So we got to 100, right? If you ran into this issue, we got to 100. If you cut and pasted them in this order, it would have given you the points that you were looking for, and now we're at 100. So this is it. This wraps up Packet Tracer Activity 11.3.1.1. I thank you for hanging with me. We're a little over 90 minutes here, but this was a monster activity. Lots of things going on, including the bug. And now you know why I wanted to cover it at the very beginning. I didn't want you to have to wait 90 minutes to figure out what the issue was. So again, I've had an absolutely fantastic time this term. There have been some phenomenal questions related to the Packet Tracer activities. I really hope that you walk away with a deeper understanding and mastery of CCNA security level tasks using the ASA firewall, using the iOS and all of the things that come with the iOS, the zone-based policy firewall, the iOS IPS functionality, all of the security features we looked at with Spanning Tree and on the switching side. So fantastic activity, great way to wrap things up. I really appreciate your guys' time. Thanks for watching. Enjoy your weekend, and I will hopefully maybe see you in another class sometime soon.